Hello, everybody. I'm going to talk a little about some work that I've done in the past and the kind of work that I do generally. But the first thing I'm going to do is actually turn on a 3D printer to print something. This should take about half an hour. So what I'm hoping is that I can kind of check in and out of the machine as it's making these little parts, which I'll explain in a while. So I'm going to swap over to another view here, and you should be able to see the top of a 3D printer.
Yep, that's perfect, Ed.
Okay, so I'm going to tell it what file to print, and that's going to take a few moments to warm up. So yeah, I'm primarily a sound artist. I kind of started my creative career as an electronic music producer and somehow ended up being a designer of sorts. The reason I ended up kind of getting into making things out of physical material as opposed to vibrational material was to build musical instruments that I could use in my music production. It was kind of a way of getting a very unique sound. I figured if I made something myself, nobody else would have that thing. That's easier said than done, obviously. So I spent quite a number of years learning how to actually design and how to make things. I'd never really done any woodwork or any of that kind of stuff before. I guess what drew me to using the technologies that we're going to be talking about today was the fact that I was already using a computer and quite high-tech digital tools with audio production. So it kind of wasn't too much of a jump for me to move from using that sort of software to using visual software. And then by extension, finding out more about machines that could be used to actually fabricate things. So I'll just quickly show you some of my work here on my Instagram page, because I find Instagram is kind of a nice platform for sharing my work, because a lot of the time what I do is quite strongly visual, as well as obviously having an audio component. This is actually this is where I'm kind of sitting right now. So you can see this nice white background is actually surrounded by a lot of clutter and creative mess. So I primarily use this technology for making sound installations and musical instrument parts and various other kind of little bits and bobs, like kind of mechanical pieces. These things, a lot of the time, will make sound to some extent, or be used in the production of sound. So you can kind of get the idea there. Electronics is another thing that I spend quite a lot of time designing, which is using similar CAD tools as what I'll show you in a minute, but specialized for electronic design. So you can check that out yourself if you want to have a look at my Instagram. So 3D printing, right? I guess my background in it was knowing nothing about it about maybe 10 years ago. Doing some night courses in metalwork and hearing people talking about it there, and kind of thinking that doesn't sound like it could be of any use to me. But then I got introduced to somebody who had a laser cutter. Now, a laser cutter is essentially a 2D cutting tool. It doesn't do 3D objects, but the reason I'm discussing it here is it's kind of, it would be my preferred tool for making certain things. Like you can see this is a 3D object, but it is made out of 2D like flat pieces of material that are joined together. So of course, flat material can be joined and made into 3D objects. Oh, that sound in the background there is the 3D printer kicking into action. Let's just quickly have a look in at that. Okay, so that's just kind of getting set up there. Yeah, so 3D printing, as you will see in this tutorial, is pretty slow. Laser cutting is very fast. So let's see. I'll just had a little video there. Bear with me one moment. I got my laser cutting video. So a laser cutter, I bought a laser cutter a few years ago. It can cut wood and plastics and is pretty expensive. So the one I have is a Chinese made machine and it costs about 10 grand. So you can kind of see it there, the red machine. I was lucky enough actually to do a local enterprise office project that was backed by the Crafts Council about 3 or 4 years ago, and got a grant to be able to buy this, and it's been transformative really in my career. So that's just me loading some material and loading some MDF into it, which can then be cut. So yeah, basically 3D printing, CAD, laser cutting, CNC machining. These things all really depend on firstly knowing what you want to make. That kind of goes without saying, but I think it's worth saying anyway. So all of my ideas begin in these notebooks. So firstly, well, obviously they begin in your head. Ideas become reality in the form of sketches. And then through those sketches, you can have an idea of the scale of things that you need. So say, for instance, okay. Right, so tools. This is just basically the view in front of me here. On the left-hand side of the screen is the computer mouse. On the other side is a special type of mouse for rotating 3D models. In the bottom left-hand corner is a digital Vernier Calipers, which is a very precise measuring tool. And beside that was just a metric ruler. So obviously, when you're designing things that are going to be fabricated, you need to know the scale and you need to know exact measurements. So generally, the process that I use is to go from designing something on paper, just kind of roughly figuring out proportions and type of material I'm going to use, and some kind of rough measurements. But I will then work that out in usually I use AutoCAD. So AutoCAD, CAD is computer-aided design and digital design tools, basically. So I'm showing here Autodesk's AutoCAD. This is just a pretty kind of industry standard CAD program that's been around for a very long time. It's used a lot by architects and civil engineers, people like that. It can do 3D, but it's really bad at it. So for 2D drawing, this is my go-to. It's quick. It's not easy to use. It took me years to learn it, but it's very powerful. So I can very quickly put in measured dimension drawings there and output them to the actual software that's needed to control machines, be it the laser cutter or the 3D printer. This is a part that I was designing for basically a tuner for a stringed instrument, which I'll show you now in a second. Okay, so it's this part here made out of MDF. The white part is 3D printed, and it's basically a tuner for a guitar string. Usually, what I would use for that is a kind of a very fine threaded metal post called a zither pin, but you need a special tool to be able to actually tune the thing. So I decided to make my own one that can be tuned with this like kind of a thumb screw sort of thing, and a geared part that can lock it into place. So what is next? Okay, so basically 2D CAD is fine if you're making flat things, but if you want to make something out of 3D parts, even if it's going to be stacked, it is possible to do in AutoCAD, but it's really not very user friendly. So something that I have taken the time to learn is a 3D CAD program called Fusion 360. There are a number of 3D CAD packages commonly used. Google's Sketchup would be a free one, which is kind of, I think it's maybe useful for certain situations, but I find it a bit clunky for making kind of small parts like these. And then Solidworks would be kind of an industry standard program that would be used by mechanical engineers and product designers, people like that. It's very expensive. I think it's a kind of a subscription model where you have to spend, I think it's around 1,500 euros a year. They're obviously aiming at that industry that can actually afford to pay these kind of costs. Fusion 360 and basically all of the Autodesk software is free if you're a student or if you pretend to be a student. So I have unofficially, as far as Autodesk are concerned, I've been a UL student for about 6 years. So they don't really verify if your college email is official or not. I guess they want to get people kind of using their software, and then if they're working in a commercial setting, then they pay a license fee. But this software is amazing. It's really changed the way I work, because as you can see, I'm using my 3D mouse here to just kind of rotate a model of a water wheel that I'm designing. This integrates very strongly with the electronic design software Eagle. They're basically the same software now. And for me, oftentimes I'm making things that integrate circuit boards in them. And being able to kind of design it all in the one space is very useful. So you can see how this box kind of fits around the circuit board quite well. When you're starting off, 3D CAD can be extremely frustrating. I found even rotating a model like this can take quite a lot of practice. It's a bit like driving a car in that, where the clutch has a very different response to the accelerator, for instance, even though they're both pedals. So yeah, there's quite a lot of kind kind of new concepts you need to learn with CAD, it's a process that's worth investing in. I think this is kind of, I guess, anecdotal. My own observation of how 3D printers are used in public. A lot of people buy 3D printers without taking the time to actually learn how to design stuff. I mean, I just personally don't see the point in getting a 3D printer unless you can actually design stuff. You can use, there are resources available on the internet where you can download models that other people have designed, and that may be useful up to a point. For me, everything I do is custom. So I even if it's a part that's similar to a part that already exists, I might need custom features on it. And I find it's just kind of more flexible to actually design things myself. So I'll just kind of give you an idea of things you can do with 3D CAD. This is the way I'm using it. There's kind of two types of 3D CAD. There's this sort of mechanical computer-aided design, which is very tightly locked to actual measurements. So say that diameter of that circle is 32 millimeters or whatever. You can see I'm extending it by 20, 30 millimeters. And then there's a more sort of free-form modeling that would be used in character animation. So Cinema 4D and ZBrush and things like that, where they're more like sculpting tools. They're more freeform. They're less constrained to actual dimensions and more about just making shapes, kind of morphing organic curves and things like that. So depending on your application, you might want to consider looking at different types of CAD software. For me, it's all, I'm making actual things out of materials, so it kind of has to be fairly exact. So moving on to the actual 3D printing process now.
Ed, would it be okay to jump in with some questions that we've gotten so far?
Sure, yeah.
Brilliant. Sorry, we've a few of them piling up, so I just wanted to start. That's okay.
Yeah.
Some of these you might have kind of answered already, but just in case I'll go through them all. So Sarah's wondering, can you print exact Pantone colors? How strong is it, and would you be able to wear it as jewellery?
Pantone colors, not with the printers that I've used. There are printers that you can, it's more like laser printing, you know, like the actual 2D, like color printing, in that it kind of layers, I think it maybe stains the material as it's going out of the nozzle. So you can get color 3D models, but in terms of, you know, matching Pantones, no, not that I'm aware of. Generally, what happens is, I'll just show you here on the actual 3D printers in front of me. That is loaded up with white filament. So all of that model is going to be white. You can get printers that have the ability to print multiple colors kind of either simultaneously or one after the other. But yeah, I think the range of colors is probably not as wide as Pantone. You can do quite a lot in terms of, once the thing's printed, spray painting it, kind of surface finishing, that sort of thing. Second question, how strong is it? It depends, right? It depends on the orientation of the model. So let me see. Basically, the way 3D printing works is it starts at the bottom of the model and it works its way up in layers. So say this part here, okay? I'm just gonna put a plane here. So this is, so say that this is the 3D printer. It's gonna start on this bottom part. It's gonna make kind of a circle, and then it's gonna slowly work its way up layer by layer. And each layer is maybe like 1/10 of a millimeter in thickness. So it's quite detailed. But as it's going up that way, the it'll be very strong. Oh, actually, can you see my video there? No, sorry. I could see what I was talking about, but you couldn't.
Sorry, you've just switched over. That's fine.
Yeah. Sorry, what I was saying was the 3D the laser cutter or the 3D printer will start at the bottom of the model, and it'll kind of work its way up slowly in layers, and in very thin layers. But what that means is that, say, kind of along the grain like this, on this kind of axis of it, it's going to be quite weak, because if you compare it to, say, wood, if you can split wood along the grain, but not across the grain. Across the grain, it's very strong. Along the grain, you can kind of split it along the length of it. It's the same with 3D printing. And I'll just see if I can actually break apart here for you to kind of give you an idea of what I mean. In general, this type of 3D printing is very strong, but hopefully this will zoom in.
Yeah, we can see.
Okay, so you probably can't see this in high enough resolution, but it's kind of lines going across. So it's from every time the nozzle of the 3D printer moves up 0.1 millimeters, there's a kind of a visible line. But using my pliers, I should be able to break this. This is a live demonstration now, so it's quite possible I won't. But... oh yeah, so you can see that that's split quite easily there.
And Sarah's wondering, could you use CMYK instead?
No, I mean, I would, to be honest, I would kind of think of it differently to printing in the traditional kind of print media sense. You're constrained to the color of the actual material itself. So I will show you just quickly here what my yeah, so you can see on the right hand side there's kind of a spool. The material comes in this sort of format, so it's an extruded line, kind of a wire of material, of plastic. That is fed up through a motor, kind of feeds it into a heated nozzle and squeezes it out. So it begins as like 1.7 millimeters diameter, and it's squashed down to 0.4 millimeters with this type of printing. But it's, yeah, it's not so easy to kind of just decide on what part's going to be a certain color. It's determined by the actual material itself. The question you had about is it suitable for jewelry? There's certainly lots of people doing jewelry design using 3D printed parts. Some use it for actual finished parts, like that they sell. And there's some amazing design out there of really organic forms that would be impossible to make any other way. And then other people use it as a kind of they use 3D printing as a secondary process, as a kind of a way of making either mock-ups of a shape and, kind of for a form and fit model, to test to see if something's the right size or if it fits or how it feels, that kind of thing. But actually then use more traditional materials like stone or metals or whatever for making the finished piece. And then there's there's the possibility of using 3D printing as making molds for casting. So it's less with this type of printing. This is called fused deposition modeling, or FDM printing. Fused deposition basically means what the 3D printer is doing now is squeezing out molten plastic, and it's being deposited, and it's fusing through heat. It's kind of melting onto the layer beneath it. There's another type of modeling called SLA, stereolithography, which uses vats of resin, so resin plastic, and it melts it with a laser. And that kind of modeling it can make much more detailed models, so would actually be better suited for jewelry design specifically. It is 10 times more expensive, and I speak from experience here because I have a Formlabs 3D printer here in the studio, and a liter of the material costs like 180 euros, and a kilo of this material in the 3D printer that you're looking at now costs about 25 euros. It's kind of comparable in terms of the amount of things you can make with it, but in terms of resolution, the SLA, the kind of the resin printer is way better. So any other questions there before I move on?
Yeah, sorry, we actually have quite a few. A couple of people want to know if you can make the files in SketchUp.
Yes. SketchUp, definitely, yeah. There's a lot of online tools as well. There's Tinkercad, another Autodesk software actually, which is quite cool in that 3D modeling is not the only thing it does. It can also do Arduino mock-ups and electronic circuit design, stuff like that. And it's you can use it in the browser. It's free. There's another one called Onshape, Tinkercad. Oh, I mentioned that already. Yeah, there's a few. For kind of basic things, it's simple enough to kind of make a primitive shape. So like a kind of a box or a sphere or a cylinder, something like that. And to start editing it. So yeah, any other questions?
Yeah, so a lot of people want to know as well, is there anywhere you can go and get your work printed if you don't have access to your own 3D printer?
Yes, and actually that brings me nicely onto my next point. But there are places called Fab Labs, makerspaces, hackerspaces, and there's tech spaces, yeah. So basically, and actually a lot of libraries now have 3D printers, so it'd be worth checking with your local library. I know I'm based up in Donegal, and I know in Letterkenny the library there has 3D printer, and I wouldn't have thought they would, but it's becoming more and more common. A lot of schools that have them too. Fab Labs, I mean, I lived in Limerick City for a while, and the Fab Lab there is a really amazing resource for residents of Limerick City. It's set up by the School of Architecture in University of Limerick. And basically they have machines like laser cutters, 3D printers, CNC machines, which are kind of big wood carving machines. They will instruct you on how to use the machines in a kind of like a 2-hour introductory course. And then once you've been trained and kind of certified to be able to use the machine safely, you can come in and you basically pay for the material and the time. There are also online services. There's quite a few for for the gamut of scales and, you know, quantities that you need. So you could get 10,000 parts made with 3D printing. Not that you should or would want to really, because it would take a long time and cost lots of money. Or you could get it one off. And this Shapeways, I think, is one of them. You can, with some of the 3D printing companies, you have access to machines that are like insanely expensive, like industry standards machines that can print titanium and things like that cost €500,000. To put it in context, like the 3D printer that I have in front of me cost, I think, €280 or something, very cheap. Even compared to the cost of it maybe 5 years ago when I last looked at prices. I just bought this machine a few months ago. And just I'll just mention this in passing, but the reason I got this was for a science gallery Dublin project called Plastic. I bought 2 of them because I needed to make a load of parts for an installation I was building. And then the coronavirus pandemic hit, and there was a very clear shortage of personal protective equipment. There still is, but in particular face shields. And I was kind of, people I know in universities and stuff had kind of told me about it from the very get-go. There was a Facebook group that was trying out different designs and trying to see how they could use their 3D printers to actually help make these parts. So there's a brand of 3D printers called the Prusa, designed by a guy called Prusha, who lives in Czechoslovakia, and he designed a headband for face shields. So basically, the thing that kind of sits onto your forehead, you have a bit of elastic on the back, and then you have a clear piece of plastic on the front. I found that there was a group of people in Donegal, kind of organized mainly by the Teachers Union of Ireland, so the teachers that were in secondary schools that had 3D printers, and various other people, including myself, started making these headbands. So we're not the only ones that were doing it. Since basically about 2 weeks ago, a company quite close to where I am in Gweedore is now mass producing like 1 million a week. So there's no need for 3D printing people to do them. As I've said a couple of times, 3D printing is very slow. You can kind of see even the progress of this machine here is it's handy enough for a little part like this, but if you're making something the size of the face shield, like it was taking 24 hours to make 4 of them, which is pretty slow. LIT in Limerick, actually the guy here in the video, Michael Mclaughlin, he's one of the guys that was instrumental in running the Fab Lab in Limerick, and is now a lecturer in LSAD in Limerick. And I would have learned a lot from him on all this technology when I was living in Limerick. They had a kind of a bigger pool of people to work from down in Limerick, Tipperary, Clare, kind of that area, and they were able to make 5,000 a week, which is pretty amazing, using 3D printing. So yeah, any other questions? So I know it's like 20 to 4. I'm in no rush, by the way, so by all means, if people have questions, bring them on.
That's good to know. We'll keep you hostage here all day on Zoom. And yeah, no, we do. We have a few more. These it's kind of a 3-part, but it's all kind of related. So, what brand of laser cutting would you recommend? Is there much maintenance involved? And then Mary asked, do you recommend an inexpensive 2D laser cutting machine for small pieces of acrylic?
So the first one was, can I recommend a laser cutter or a 3D printer?
It's what brand of laser cutting are you using?
Oh, it's basically a Chinese. It's kind of a generic Chinese machine. The laser cutter. It's imported to the UK by a company called RS Laser, and they upgrade the electronics and make sure that they work because they're quite sensitive machines. There's kind of a laser bulb in the back of the machine that can break very easily, and oftentimes they're not manufactured very well. Like sometimes the electronics can be kind of dangerous in them. So while you could buy it cheaper directly from Alibaba or somewhere like that, directly from China, you're taking a big chance that it might not work. And unless you're a mechanical engineer, which I certainly am not, you could be in for a bit of a nightmare. So getting the company that imports them, make sure that they work, incurs an extra cost, but I think it's well worth it. And I bought my one because I knew I used to work in NCAD in Dublin, and they have the exact same laser cutter, and I was well familiar with it, and it worked. It's reliable and reasonably cost for what you get. That one was, I think, €8,000, but it's quite a large bed. So the bed is the actual usable area that you can fit material into. And this one is 1200 by 900 millimeters, which is 4 by 3 feet, if you want to use that way of measuring things. In terms of using, so kind of a smaller scale laser cutter, you can definitely get smaller ones. They sometimes aren't as powerful. If you have more money, if you like, say, if it's for a business that you're going to be getting return on your investment pretty quickly, I would have a look at Epilog laser cutters. They're American made. Trotec as well as another European made company, very high quality, but they're kind of, say for what I need to do which is I don't need to do engraving so much as just actually cutting out material. I've never had any problems with the Chinese machine, whereas the higher tech ones like the Epilogs I used in University of Limerick and had constant software problems with. So the hardware is amazing, the software is awful. Whereas the Chinese machine, the hardware it's a workhorse. The software is so basic, it doesn't really do anything. So not a lot goes wrong with it. You can get small laser cutters. I think there was one on Kickstarter that I actually initially backed years ago, and it took so long. There was delays with it of like 2 years or something that I got a refund and bought this machine instead. There was a question in the middle. I know that kind of answers maybe the last question. Oh yeah, maintenance. There is a bit of maintenance.
I just want to know if there's much maintenance involved.
Yes, with both 3D printers and laser cutters, there's a bit of maintenance. Cleaning, say with the laser cutter, there's a beam of light being kind of bounced off 3 different mirrors, and those mirrors have to be aligned very, very precisely to actually focus the beam through the part that actually sends the kind of very focused beam down to cut the material. And that there's a technique to it. Basically, it was pretty tricky trying to figure it out though. Similarly with the 3D printers, there's the ones I've had now that they've been working constantly because they've been doing these faceband or headband things for the COVID shields. They've been working pretty much around the clock for months between my art project and this kind of health PPE project. Beyond setting up initially, you basically have to make sure that the nozzle, which is the part that it squeezes the plastic out, molten plastic out, that has to be oriented to the bed of the 3D printer in a very exact manner, or else you have failed prints. There is quite a lot of trial and error with this stuff. With these cheaper machines, because basically the history of 3D printing is that it was a patented, like this type of 3D printing was patented up until I think about 10 years ago, and then it became kind of open source and was developed by the open source hardware community using very, like, relatively very imprecise technology compared to the really expensive machines, which are hundreds of thousands of euros or dollars or whatever. So there's always been that kind of, I mean, it's becoming less and less now, but its history is very steeply embedded in the kind of hacking community, like people that are comfortable with making machines, and they are becoming more user friendly, like consumer friendly, but there's still quite a bit of messing around that you have to do occasionally. So I hope that answers your question.
That's great, thanks Ed. Okay, I think I've got 2 or 3 last questions, so I'll go through them quickly. One was, what kind of filament would you recommend for jewellery? So they've got a couple of examples like PLA, nylon. So just, that was one question. Another one is, do you recommend a model of a 3D mouse that you use? And finally, do the pieces have to be filed or treated to get the surface clean when they come off the printer?
So the first question, PLA or nylon. Nylon is going to be stronger, but I think it's harder to print. I think it needs higher temperatures, and it can be more expensive. PLA is very cheap, but it's not very weather durable, and like it'll deform with heat, like not, I think 60 degrees heat, which could be an issue. Like say if you had a piece left in a car and then or a glass house or whatever, you could easily get those temperatures and it could start melting or just kind of disintegrating over time. Nylon probably won't have that problem. It's a very tough material. There are loads of different materials you can use with 3D printing. Like PLA is kind of the most common one. It's a polylactic acid, so it's based on it's extracted from plants, I think, so it's kind of a natural plastic. It will biodegrade, which is an advantage. There's ABS, acrylonitrile butanidate or something, I don't know, some very hard to pronounce chemical name. That is a very common material as well, a lot more durable, but it's a bit trickier to print and doesn't biodegrade. What was the second question then?
The second question was, do you recommend any model of 3D mouse that you use?
Oh yeah, I would absolutely recommend this 3D Connexion. So it's CONNEXION, 3D Connexion, and this is called the Space Mouse Wireless. It's a bit more expensive than the Space Mouse, which is a wired one. I found the wire in the same way like a mouse, like a kind of traditional mouse with the wire is always getting in the way of things, and I just didn't want to have to deal with it. So this one's Bluetooth, and it's got a little battery inside. You have to charge it up every couple of weeks. It's very sensitive. It can do kind of like 9 degrees of movement, I think. You can kind of zoom and pan, tilt and rotate. Takes a bit of getting used to. Like it's a very sensitive tool, but once you get the hang of it, it's indispensable. It'll be just, you save so much time in 3D modeling if you can actually just see what you're doing by rotating the model or panning or whatever. And having a dedicated tool as well as the mouse is, I find, a really useful workflow. The next question.
The next question was, do pieces have to be filed or treated when the surface, or when they come off the printer to get the surface clean?
It depends, but yes, like if you want to have, and actually this is what put me off this type of 3D printing for so long. The surface quality can be a little kind of rough, and sort of, I don't know if you can really see on this model, but this is actually pretty good. Now, the 3D printers are definitely getting better. And on a model this size, it wouldn't really be practical to sand. But yeah, I mean, there's a couple of ways of doing it. You can, I think people use rubbing alcohol, like isopropyl alcohol, or no, acetone, sorry, the stuff that's in nail varnish remover. That will sort of chemically melt the material a bit, and then that kind of striation, if that's the right word, will sort of become more smooth. You can use sandpaper as well, and you can definitely paint and otherwise kind of stain these things quite similarly to how you would with wood. But yeah, like I say, it depends on what you're making. If surface quality is really important to you, I would consider looking at the SLA type printers. Formlabs are the kind of industry leaders in that type of, well, prosumer printers they call it. So professional consumer grade as opposed to industry grade, which is the more expensive machines again. Yeah.
That's great, Ed. One of the last questions I have, but if anyone has any more, please just keep typing them in. But Orla was wondering, is it a sustainable process and is it kind to the environment?
There's a couple of schools of thought on that. So is it kind to the environment? In some ways, yes. Additive manufacturing by its nature uses less material for making things, like compared to traditional manufacturing, which is subtractive manufacturing, where you typically have a block of material that parts are removed from to reveal the finished shape, in the same way that you would carve a piece of wood or a piece of stone. So you've got all that waste material left over. Additive manufacturing only uses the amount of material it needs to make the thing. But where it saves in material, it will make up for in energy use. So even this printer here in front of me, you can hear there's a fan, or maybe you can hear it, or maybe you can't. The motors, the stepper motors that are in it, consume not a huge amount of power, but it's not really a scalable sort of process. For that reason, it uses up a lot of power for making the parts it does. For making one-offs and things like this, it is far more efficient than traditional kind of mass production processes. Again, in terms of the materials, I don't know, it's kind of interest to me is how plastics generally are recycled, and 3D printing, there's a lot of kind of failed parts, or else iterations of a design maybe that aren't suitable for your end use, and they tend to go in the bin, which is just adding to plastic waste. But there are solutions for that. Like you can actually shred up plastics if they're the same type, and you can extrude them if you have the right kind of machines to do that. And you can actually repurpose the plastic to make more things. there's more kind of commercial solutions coming online for that, but it's, yeah, to do it properly requires quite a lot of money. So it is something I'm looking at the moment. I think on a kind of a municipal level, it could be useful for 3D printing communities to have access to machinery that can actually, they can recycle their prints, their failed prints, and make reusable material, and that they can buy at a discounted cost. Because certainly here in Donegal, I mean, through that, the face shields project, there's maybe 30 people with 3D printers in Donegal, which is not the most sparsely populated area in the country. I was really surprised that there was that many people using 3D printers. So if you take somewhere like Dublin, there's going to be probably thousands of people with them. Well, hundreds anyway. So it's maybe not too far-fetched an idea to have a resource center for that particular thing. For instance, plastic bottles are made of PET or PETG, it's type of plastic, and that can be recycled for 3D printing materials. Any other questions?
Yeah, Orla was just following up with that, Ed, and she was saying, do you think eventually that there will be an eco-filament that will decompose?
Well, this one, PLA will decompose because it's made from, I think it's some sort of plant resin. It's definitely a plant-based plastic as opposed to an oil-based plastic, which most plastics are. There are, I mean, there's really interesting work done by, she's an architect, Israeli architect, Oxman, I think her name is, could be Nelly Oxman. She, as far as I know, works in the MIT Media Lab or one of these kind of places, and had developed a filament that's made from crushed seashells. So it's, I think it's keratin, but basically it's the material that, say, snails use for making their shells. It's very strong, but it biodegrades. And she made it in such a way for making these kind of structures that once you put them into water, they dissolve. And there are soluble 3D printing materials that are plastic based, but I really liked that that idea of using a type of waste, because if you think of all the seafood, the shells just go in the bin, you know, they're, and on industrial scales, it's maybe one of these kind of loops that can be closed, that materials that are naturally produced can be reused to be useful for this kind of technology without too much modification to the actual machinery.
Great. Yeah, a couple of people are putting in the name there. So yeah, Neri Oxman. So there you
Neri
go.
Oxman. Yeah.
There you are. A few people, thanks everyone for putting that in. A couple of people are just saying thank you so much, and especially for answering their questions, and that it's a really fantastic webinar and really informative. So thank you, Ed. I suppose, I think everyone is just kind of, we're getting a lot of thank yous and how helpful it is. Do you have anything else you wanted to add?
Not really. I mean, I would say if you are interested in this, now is a great time to investigate it. Like I said, I was aware of it for a long time, 3D printing, and didn't actually buy this type of 3D printer until January this year, because they have become so cheap. Actually, I would recommend the machine that that you are now looking at. It's called, I'll actually just type it into the chat here, because then it's called Creality. Chat. Yeah, so Creality Ender 5.
Yeah, and thanks for typing it in. Actually, a couple of people are saying it's great to get recommendations for actual machines, so that's really helpful.
There's a bunch of them on the market at the moment, and a lot of them are very similar they're, you know, like a lot of them are Chinese made, and they've just come on leaps and bounds. Like they're actually, this one, it kind of comes in a, it's partially assembled. It takes about half an hour to put together with an Allen key, and you know, it's very well documented in how to actually put it together, both through the manual and through accompanying videos, and just a user sort of user base in that share their resources through the internet. Whereas before, like a few years ago, you just have to really know what you're doing to actually make one. That one, like I said, cost, I think it was under 300 euros anyway. And considering what it can do, I think that's really a no-brainer. You can get them cheaper than that, but yeah, just do a bit of research before you do. Kind of take the plunge and buy one. But mainly, yeah, spend the time. If you're new to it, 3D CAD, learn how to do 3D CAD. It's a transferable skill across different types of fabrication. Even if you're making something by hand, you know, like through traditional craft means, being able to 3D model something to figure out how you're going to build it is hugely beneficial. And I would definitely recommend learning CAD at the same time as, or before even, investing in 3D printing. Otherwise, it's kind of, a lot of 3D printers, I think, maybe are used for making novelty things like key rings and Star Wars related paraphernalia, which I wouldn't have a whole lot of time for, when it's such a useful tool that can actually, it's really a very handy thing to have in your workshop if you're a craftsperson or designer.
I have to say, I think that's the comments and feedback we're kind of getting, is that, you know, how transferable those skills and knowledge are. And one person has commented saying that they've done some work in augmented reality already, and they've done sculpture, and now they're looking into mixed material jewellery, so that this is kind of a great crossover material to consider.
Mm-hmm. Yeah, well, I mean, like I say, if you have some visual design skills, like software skills, a lot of these things, a lot of these programs, they'll share terminology, or you'll be able to share the knowledge you have of one thing, and you'll be able to transfer it to another. So, you know, I think what can be tricky with 3D CAD, and because I taught 3D CAD with AutoCAD in the Dublin School of Design for a while, and I think what can be difficult with it is kind of the understanding it conceptually. There's basically, you have to make so many decisions with a design as you're doing it. You kind of have to figure out in your mind how you're going to do it before you can get the software to do it. Maybe that's something that will become easier as technology develops, but at the moment it's kind of, you just have to learn it. And if you've got some design skills, like say if you're familiar with say Adobe Illustrator or those kind of 2D drawing tools, that will definitely help you in learning 3D modeling. So any other questions?
That's all great. We don't seem to, oh, let me see, sorry, we've got one more. George is saying he's from an architectural background, and that this will help for getting designs to reality, and currently playing with ceramics. So thanks, George. No, it's really lovely to hear all the questions and feedback from everyone. I think we'll probably finish up there. We're just on an hour at the moment. Ed at the start of this was like, will it be half an hour? I told him it would definitely be longer with all the questions. So it's always good to get input from everyone who's participating and attending the calls. So I just want to say a huge thank you to everyone for all your questions today. If you're interested in any other webinars or workshops, Get Ireland Making will be hosting them over the next few weeks. So just keep a lookout on Design and Crafts Council Ireland's social media and their website for more information. I think the next one we have is with Laura Quinn, and that's going to be on glass design. I think that's on the 26th of May. So if you want to keep a lookout for that one. But again, a huge thank you, and especially now to you, Ed. You put a lot of work into that. It was really wonderful having the 3D printer going and seeing the videos. So really.
Oh, I didn't actually show you the parts I made. Sorry, this is like it's just an end cap for this PVC pipe. Actually, there's one in there already. Yeah, that's pretty utilitarian sort of use for it. Yeah, sorry, go on.
It's great to see something being made in the process, and yeah, to have it going on. Thanks for that.
My pleasure, and thanks for everybody who tuned in and was interested in it, and get in touch with me if you ever have any other questions, or indeed if you want anything made or designed. I have facilities here in my studio for doing that. Fabrication is one of my one of the activities I do to make my living as a designer, artist, maker, sort of thing.